Hello everyone, I am Maheshwari, Assistant Professor, Department of BSc Information Technology at Dr. S.N.S. Rajalakshmi College of Arts and Science. Now I am going to explain about memory management in operating system. OS performs various process and schemes for process management. Likewise, it also performs memory management. It's a very important key components of OS activities. Memory management is the key functions of operating system that handles allocation and deallocation of memory space to user program and process. For example, we have a number of user programs executed simultaneously by the single OS, but all the process can be stored inside a memory with the help of memory management scheme. Likewise, every process should reside over the memory. For that, OS provides proper memory management and enough storage to the process. This is done with the help of memory management. The importance of memory management, which ensures efficient utilization of computer's memory. It prevents conflicts and overlaps between the process, improves system performance and stability. This is the very important features of memory management. Key functions. The first one is tracking memory. It keeps the records of memory usage. That is, these records stores the available and unavailable spaces about the memory. Allocation, which assigns the memory to the programs. Deallocation frees the memory after the program execution. Before execution, it should be reside over the memory. For that, we have to allocate some space. After completing the execution by the processor, the memory space should be freed for another process. That is called allocation and deallocation of memory. Swapping, it moves process between main memory and the disk. Types of memory in an operating system. There exist two kinds. The first one is primary memory and secondary memory. In primary memory, volatile memory used for active processes, faster but limited in size. That is what RAM. And secondary memory is about ROM. It is a non-volatile storage. It stores data and programs which is not in use. Virtual memory, it extends RAM using disk space, enables multitasking by swapping data between RAM and storage. Cache memory, it is small high speed memory for frequently used data. Cache memory lies between a processor and the main memory, so it transfers the files between the processor and the main memory. It has only a limited size of memory space. Memory allocation techniques. The first one is contiguous memory allocation. It allocates memory in a single contiguous blocks, simple but prone to fragmentation. For example, the total memory can be divided into equal number of parts. These parts can be allotted for each process. It is a simple mechanism, but while fragmenting, it should be very complex. Non-contiguous memory allocation, it divides the memory into fixed size of blocks, which is called as paging, or variable sized blocks, which is nothing but segmentation. It reduces the fragmentation and allows better utilization compared to contiguous memory allocation. Paging, it divides the memory into equal sized pages. It maps the process pages to memory frames. Segmentation, it divides the memory into logical segments, provides better process organization. Challenges and future trends. Challenges in memory management, which includes fragmentation, wasted memory due to inefficient allocation, tracing, excessive swapping causing performance degradation. Scalability, managing memory for increasing workloads. This is the major challenges available in memory management. So OS should avoid these challenges and prohibit the challenges, and after that it should be it should allocate memory space for the process. It's the challenging area for memory management to the processor, to the OS. Future trends. AI driven memory management, it predictive allocation for better performance, improved virtual memory techniques, faster and more efficient swapping, hardware advances, integration of non-volatile RAM and for faster access. These are all the very important memory management techniques which can be available in future of operating system performance. But in nowadays we are using different allocation schemes and different mechanisms to allocate memory for processing. Since each and every things should be recorded over the memory by the operating system for future reference, so that memory management scheme helps to organize memory space and utilization of memory will be equally shared. Here, memory is also another important resource while for processing. So the memory also can be managed properly. An operating system performs process management, resource management. Likewise, it also performs memory management scheme. That with the help of this scheme, the process can be stored and accessed properly by the devices and the processor. So this is the very important thing of memory management of an operating system. In future we can apply some AI driven based memory management schemes for complex tasks and number of when the process numbers may be in high. So this time we can use advanced management schemes in future needs. Thank you.